Hello, this lesson is for Wednesday, May 6th. Today we are doing lesson 122, coordinate planes. And I'm sharing my screen with you today so that I can explain how we can create and use coordinate plane systems to identify locations and read maps. So yesterday we came up with really effective way to locate locations on a number line. And today we're going to create a more complex way of locating things called a coordinate system or coordinate plane system. So in order to do this correctly, we need to understand basically the way that lines intersect and the way that lines work. So there are two types of lines that we've discussed, or two types of line relationships that we've discussed in the past. So this should be familiar to you. So the first word is perpendicular. Perpendicular means that there are two lines that intersect at an angle of 90 degrees. So here's an example of what perpendicular lines look like. They intersect at a right angle, 90 degrees. The other type of line relationship you need to know is parallel lines. Parallel lines are two lines that will never intersect. So if you look at these two lines here, if they continued on, they are not going to intersect ever. Intersecting just means crossing at some point. They can cross at the top, bottom, middle, whatever. If they intersect, they are not parallel. If they don't intersect, then you can call them parallel. So perpendicular lines obviously are not parallel because they intersect at 90 degrees. So let me just start out with testing out how well we can understand parallel and perpendicular. So this is a map of a city called Stony Brook Village. And there are two situations where we need to add lines or streets. So let's look at part A first. It says the town wants to construct two new roads, Elm Street and King Street. Elm Street needs to intersect Lower Sheep Pasture Road, but also run parallel to Main Street and be perpendicular to Stony Brook Road. So if we were to draw a street called Elm Street, it needs to be parallel to Main Street and perpendicular to Stony Brook Road. So here's Main Street right here. So this new street needs to be parallel to it, meaning it can never intersect it. And it needs to be perpendicular to Stony Brook. So here's Stony Brook. So that means it needs to cross Stony Brook Road at a 90-degree angle. And if that's the case, will it be parallel to Main Street? Yes, it will. So let me show you how that looks. It's kind of hard to draw a straight line using this marker, but I'll try my best. So this red line can represent Elm Street. Another example of that is right down here. This example is completed, Elm Street, right? Now it says part B, King Street can be perpendicular to Main Street and start at the intersection of Upper Sheep Pasture Road and East Main Street. So we need to sketch King Street. It has to be perpendicular to Main Street. So instead of parallel, it needs to be perpendicular. And it needs to start at this intersection where East Main Street and Upper Sheep Pasture Road begins. So I'm going to sketch my road. There we go. So this road here is called King Street. And as you can see on the completed example down here, King Street is perpendicular to Main Street. It intersects it at a 90-degree angle, and it starts at this intersection, whereas Elm Street is parallel to Main Street. So this was just a quick example of a map and how we can draw lines that are parallel and perpendicular. All right, let's take a look at example B. Now, I know I have a lot of writing on this page, but that's because this is a lot of information, so bear with me. So we kind of already talked about this, but we're going to do something today called creating a coordinate system. And a coordinate system is when you use actually a set of perpendicular lines to plot points that are not exactly on the line. So we've been plotting points on one line. Like take a look down here at point A. We've been starting yesterday or Monday, we started plotting points on lines, right? So point A is at 1.5 on this line. But what if we have to have something that's not directly on this line right here? What if we need to have something that's slightly above it? So one way that we can solve that problem is by having two lines, two number lines, and we can identify the location of points on the line by using these two lines. So the first, we call these coordinates, locations, right? So the first coordinate is always the number that goes along this horizontal x-axis. The second coordinate is always going to tell us where the point is vertically on the y-axis. So again, there are two perpendicular lines in a coordinate plane system. The first coordinate is always what's on this horizontal line. The y-coordinate is always what's on the vertical line. So we call it a coordinate pair. So we can show the exact location of points in a coordinate system using a coordinate pair. They're shown in parentheses with the x-coordinate always coming first and the y-coordinate always coming second. So if we wanted to say point A was at 1.5, we could also add a y-coordinate and say that it's at 0 on the y line. So over and up. So it's over 1.5, but it's not up any, it's 0. So 1.5, 0. Look at this point, point B. If we wanted to say the coordinates of B, we could say that the x-coordinate is 1, because it's 1 over, and up 2. So over 1, up 2. So point B is at 1, 2. The coordinate pair is 1, 2. So I know that this is a little complicated and confusing. It'll make more sense when you see Are You Ready and work it out. But basically, you can use the number lines to help you plot different points. So let's say I wanted to plot a completely different point that's not on here yet. Let's say I wanted it to be at 4, 3. So I would go over 4 and up 3. And it's easier to use rulers for this. So that point is at 4, 3. Let me write that in. 4, 3. I got to write really slow with this. And then you put it in parentheses. Let's say I wanted to put a point at 2, 2. So I would go over 2, up 2. That's 2, 2. Over 7, up 1. Right there. Maybe over 8, up 6. Right there. So you can put different locations on this coordinate plane using x and y coordinates. The x coordinate is always first. The y coordinate is always second. So x, y. Again, this will make more sense later. And if you have trouble on Are You Ready, don't worry about it. Just come to the Zoom session in the morning or in the afternoon, and we will help you go over it, okay? I will see you on Zoom. Again, I know this is a lot of new information, but read through these examples that I posted and do the reteach and see if you can understand this on your own. If not, please join us in Zoom and we'll go over exactly how to do this, okay? Have a great day.